Ian Scribner. I work here with CAMLogic. Today's webinar is going to be focused at reducing your NC programming time with NXCAM. And with that, we'll jump into it. We're going to try to keep it at about a half hour, maybe a little bit longer. We will do some Q&A at the end of the session. If you notice, there is a question dialog box that will open up towards the end. All right, so real quickly, CAMLogic, we're a Siemens PLM solution partner. We're founded in 1995 here in Oxford, Michigan. We cover primarily Michigan, Ohio, Indiana, and Pennsylvania. 16 plus years strong, shown double-digit annual growth the past couple of years. Solution specialists, with industry expertise. Primarily everybody here, especially from the application standpoint, comes from the industry. We pride ourselves on cutting-edge products and services. Our focus is highly trained personnel and dedicated customer service. So quickly, the different areas that CAMLogic focuses on is primarily three different arenas, one of which is the 3D scanning side. So we work with reverse engineering and data capture for data inspection. We also get into the 3D printing and rapid prototyping. We're a provider of 3D systems, so we can provide fit functional parts as well as parts maybe more for marketing or engineering review. And finally, the third leg is the Siemens portion, the CAD, CAM, CAE, PLM, and PDM. And obviously today we'll be focusing on the NXCAM product line. So quickly, NXCAM is well established in the industry. They have many customers in nearly all industries across the world. The customers will vary from the smallest machine shops, just a single license, one or two machines, to largest international companies, areas such as automotive, aerospace, machinery. We're also closely aligned with the Siemens Motion Control business unit. Many of you people out there may associate with the Siemens Synumeric controller. NX offers a wide range of capability, and we generally divide these into three separate areas. Mold and die, typically combined techniques, high-speed milling, hard tool steels, maybe some more prismatic parts needed for tool bases. Then we work with the prismatic parts, another sector which covers generally machining and especially the kind of parts found often in the machinery industry. And then finally the complex parts. Uses cases typically associated with aerospace, power generation, medical devices, typically in 5-axis arena or mill turn environments. When it comes to the manufacturing realm, we like to think that there's 5 pieces of the pie, even though that we see far too often the customer base may only focus on 2 of these areas. Maybe they just have a strong machine tool with a great controller, or they just focus on they purchase high-end cutting tools and machine tool. But far too often we see the CAM software itself sort of left out and not looked at as an equal part of the entire pie. That's where NXCAM comes in, provides a complete source for you, a complete tool, CAD-CAM solution. So today's topics are going to include advanced programming and programming automation, also post-processing and simulation, and finally programming productivity. So NXCAM does provide feature-based machining along with process template. There's several different ways that we can automate and streamline NC programming that, in the end of the day, reduces the programming time associated with the models. Obviously, we achieve faster, more repeatable NC programs. Also, this helps reduce the required expertise that may be needed. First, we're going to discuss the feature-based machining from NXCAM. Feature-based machining, also known as FBM, will automatically recognize and program a wide range of machining feature types. This can be this can include wire EDM, prismatic features, pockets, holes, slots, even in turning inside of the NXCAM. And also another practice that we've seen used in the past that NXCAM does support is colors along with attributes, and we'll discuss that a little bit more further along in the presentation. So the NXCAM, the feature-based machining process, is primarily a 5-step process. We have first and foremost the feature recognition. And the beauty behind the feature recognition with NXCAM is it doesn't necessarily have to be designed in NXCAD for the NXCAM to recognize features such as slots, holes, pockets. NXCAM will automatically recognize these even if it wasn't designed in NXCAD. It could be a step, an IGES, Parasolid, anything imported. From there, we'll select after we recognize the features, the operations will then be selected, and then we can generate the toolpath that's created from the feature base. After that, we'll optimize the toolpath, and then, of course, output the G&M code. Feature-based machining works from what we call the machining knowledge library, which is basically a complete library of your company's industry or industry's best practices. And this library can be edited, modified to your company's own likings. Obviously, we provide an out-of-the-box solution. But from there, we typically will expand upon that for the user's needs. Feature-based machining and the ability to recognize machining features on a part model. We can also look at an NXCAD model and read product and manufacturing information, or what's also known as PMI. It's been added to by the designer as a 3D model annotation. A lot of times we'll look at a 2D print and determine the GD&T or the annotations associated with the model, but NXCAM has the ability to look at the NXCAD model and pull that same GD&T and automatically compensate for it while it calculates the toolpath. And real quickly, we'll jump into a product demonstration to show you what we're talking about.
In this example of feature-based programming automation, we're going to ask the system, NXCAM, to look at this component and to recognize the features that it can see on that part, and then to create the NC programs automatically for those features. So the first part of the process is for the system to look at the geometry and to find the features based on a range of features that are built into the library already. And users can add more features for it to recognize. The system will look at the dimensions and tolerance data as well and pick up that when it's attached to the features. Here on the left, the system has already identified this wide range of features here and displays in the Feature Navigator. And we can select any of those features and ask it to display extra attribute data, lengths, dimensions, other information that it's found about those individual features. We could ask the system to program all the features automatically, but here we're going to select just 4, 2 holes, 2 pockets, and ask the system to create programs, NC programs for those 4 features for this example. The system does that, we ask it to process it, and it puts together a sequence of operations based on the operation sets that are built into the library, and it does that automatically. We open up these 2 holes here and look at the individual operations here. We'll see that there are 3 machining steps in one of them and 2 in the other. This is because the system has recognized that in order to machine one of the holes, we have to add an extra finishing operation to meet the tolerance requirements that were attached to that hole on the model.
All right. The beauty behind the feature-based machining with NXCAM is it comes with what is what we also call the ability to a teach mode within inside of the NXCAM and the feature-based machining. It can interactively define custom feature types, and the nice thing is it's a graphics interface environment, so you don't have to know programming language or programming code in order to modify or change the machining library and find custom features and automatically apply specific machining operations and again, adjust the rules inside the Machining Knowledge editor. The next action item that we're going to talk about today is templates inside of NXCAM. Templates are one of the more powerful ways to automate NC programming, and one of the most typically often found ways that our customer base uses NXCAM to automate NC programming. You can apply predefined rules in a driven process and set up templates to speed up the programming task, ensures the use of preferred methods and tooling, and easily creates new templates or modify existing ones. How the process works with the template files is basically after you've created a template file, or maybe you want to start with one of the pre-existing template files, you can launch it from the File New dialog box. After selecting the template inside, it'll automatically bring in standard operations, standard tools, anything that on a day-to-day basis that is sort of a mundane task that you repeat, we can put inside of an NXCAM template. Each time you launch open, a lot of your information is already filled in. So template examples, this is sort of a smaller example, but even along the lines of something that where parts are similar. The top part here compared to the bottom, basically we just have some buttons on the bottom that we don't have on the top. You're looking at about a 5-time reduction on programming time. Also, this decreases clicks, which automatically minimizes errors from the programmer. Inside of NXCAM, we also have the machining data library. Primarily, every CAM software will have cut data, which is an add-on feature for certain tools like MasterCAM, GibbsCAM, and so forth. NXCAM comes with their own machining data library built right in. Gives the users the ability to manage and apply proven data to associative toolpath and operations that will automatically adjust for the given operation, the tool selected, and more importantly, obviously, the material that's selected for the part model. Another tool provided with NXCAM for minimizing programming time is what we call CAM wizards. These are used to capture and reuse company best practices. Obviously, the proverbial bus it runs over the senior programmer. We can still capture his knowledge with what we call a CAM wizard that maybe more of the novice users can just use to program a family of parts. Basically, how the CAM wizard works is the top image there, the one that mentions Die Machining Wizard. That's a step-by-step process that shows a novice user what to do on programming a part. And it'll step them all the way through tool creation, through selecting the geometry, and finally calculating the toolpath and posting it out to the machine. And it takes them through a step-by-step process. The nice thing about this is a core product that comes with NXCAM, and you can create these wizards on your own, and again, no programming skills are needed. It's a Windows graphically driven interface, very easy to pick up, use, and create your own custom CAM wizards. So the next option, or the next topic we're going to discuss is the post-processing and simulation. We can have all the programming automation that we want. Obviously, we need to be able to post-process and simulate. With each new job, there can be a lot of time spent on the shop floor. It can be often on the machine itself, checking, testing before the part is ready to be cut. By providing good output from the CAM system, you should be able to reduce this time and effort and still avoid machining mistakes. And this is even more important as machines become more advanced, with the 5-axis or multiple machining options with the mill and turn, both within one machine. The NX Post Builder is a standard part of the NXCAM. It provides an easy way to build and edit post processors. Of course, we use this tool ourselves when we build post processors for our customers, but many customers will use NX Post Builder to create and edit their own posts. We also maintain a library of posts that customers can access online from within the Siemens PLM software Global Technical Access Center. That's an image down there on the left-hand side of the library. The existing library, I would say, has anywhere between, it's growing pretty much every day, but good safe bet is going to say 250 to 300 different post processors that are already proven, used by the customers, that existing customers can go out, download, and use at their own convenience. For any customers that are using a Siemens Synumeric controller, NXCAM also provides an optimized Synumeric post processor that automatically selects key controller settings based on machining operation data. A special menu in NXCAM can enable you to select key functions on the Synumeric controller. Let's take a quick look at an example of this.
This is a demonstration of support for Synumeric machine cycles and special commands in NXCAM and CAM Express. Let's start by looking at a tapping operation. If I were to post-process this through a typical post, we would see fairly standard output, G4 tap cycles, CNR, basic G-code. However, if I take the same operation and post-process it through the new Synumeric post, we see a lot of additional information, not only commentary data, but variables being set for the Synumeric control based on information extracted from the operations of the CAM system. We have things like commands for the triary, we have commands for the orientation, or the work coordinate system and the axes. Several Siemens-specific things are built into this to take advantage of the control functions. Let's look at a milling operation that does some high-speed machining. In this case, let's post-process it first to our regular post-processor. Again, standard G-code output. Same operation, we'll post-process it through the Synumeric post. And we see a lot of additional information specific for the 840D control. Now what controls this, much of it is extracted from the operation data, a lot of it is defined by the user. We take a look at the operation itself, and I look at the machine control events in there. These are the parameters that the user gets to set. This turns on the mode for the Siemens, so these are all the variables that can be set. And they're in terminology that's familiar to the programmer who knows the Siemens 840D control and what functions he wants to activate or not.
Next, we're going to chat a little bit about the simulation within inside of NXCAM. The simplest level of simulation that all CAM systems offer is toolpath simulation. Usually with material removal from the stock shape but no representation of the machine and its motion, often referred to as a toolpath verification software. It's driven from the internal toolpath in most cases. Then most CAM systems today will even go as far as offer machine tool simulation, where we can see the part, the tool, and the 3D model of the machine tool moving. Impressive and certainly more interesting than just the regular toolpath verification. But in most cases, this is still not driven in a CAM system from the internal toolpath before it has been through the post-processing stage. In NXCAM, when we need a machine tool simulation in the CAM session, we run the operation set through the correct post-processor on the fly and use the G&M code output to drive the motion of the 3D machine tool model in NXCAM. We call this G-code driven machine tool simulation, and it has to be a closer representation of what the real machine will do with the machining operations, because it's obviously driven from the posted code. A lot of CAM softwares a lot of our customers will use another tool called Vericut for their G-code driven simulation. But if they were using NXCAM, they could obviously use the G-code driven machine tool simulation straight within inside of NX. We'll show a prime example of this.
In this demonstration, we're going to look at the use of machining simulation inside NXCAM. First, the user picks the machine tool on which he plans to run the job and selects that machine tool model from the library. The part can be transferred to an alternative machine at any stage. In this case, we're going to pick the 5-axis milling machine. It has a Siemens controller. The programmer generates the toolpath on the 3D part model from a wide range of machining options, as we see on this complex independent one. At any time during the programming, the machining process can be reviewed using the integrated simulation capability. And the system uses the appropriate post-processor for the selected machine and immediately prepares the G-code to drive the simulation. And you can check for errors, choose conditions, or limited trouble violation. In the code display window, the user can opt to see either the internal toolpath data or the G&M codes from the post-processor output. These are the codes that are being used to drive the simulation all inside NXCAM. The machine tool 3D models are built using standard NXCAD modeling and assembly functions, and then the machine tool builder option that comes with the NXCAM allows you to add the full kinematics of the machine onto that 3D model, including the axes and the limits of travel and so on.
So real quickly, just as a wrap up there, basically NX provides the flexibility to support process and specific implementation. Again, we can program, post-process, use G-code based simulation that'll drive the 3D machine tool model assembly. And we can use setup templates and examples, all within inside of one tool, NX. So last, we're going to touch base on programming productivity within inside of NXCAM. With a simple or limited CAM system, you would expect it to be easy to use. Obviously, with less functionality comes less commands, less capability. With NX, we invested heavily and applied the latest user interaction techniques across NX to ensure that the benefits of the advanced functions of NXCAM are accessible even to the newest users, providing a short learning time and making things easier for the less frequent programmer. A prime example of this is what we consider a virtual jog. Oftentimes in the 5-axis arena, we'll see customers coming in and applying a 5-axis, maybe Z-level machining technique, and they're not quite sure what the tilt or lag that they want on the tool itself. With NXCAM, we have the ability to come in and virtually create this right on the graphical screen. I'll show a prime example of this.
In this short demonstration, I'm going to show the graphically interactive programming that we have available in NXCAM. In this case, the user is able to interact with the tool and in this case, the tool angle directly on the screen to edit or, in fact, as we see in a moment, to create a new toolpath. In this case, to avoid a collision with part of the component, we want to adjust the tool axis. We do that graphically. We can do that graphically by interacting with these what we call grab handles relative to the tool, changing its angle for the start and finish position. In this case, it's passes the toolpath. Then just to recompute the new toolpath, we avoid the collision. In this second example here, we're actually using the same technology. We're using it to create a new toolpath. We're positioning the tool relative to the part graphically on the part to create this toolpath on the center line here. We also use it to position the tool for retracts, as we show here, and therefore build up a complete toolpath relative to this prismatic part. Again, a very useful tool, easy to use, to interact graphically on the screen to create a toolpath in NXCAM.
Another tool for programming productivity, again, is what we call predefined roles and tutorials. NXCAM will come with what we also call the CAM Express role. It gives the ability to select either the advanced or express role and provides a standard with all the versions of NXCAM. The express role is especially aimed towards the new user. Basically what it does is it eliminates maybe some icons and streamlines the interface for more of a beginner user. With inside of NXCAM, we also have 4 primary views, but are one of the best ones for new users, what we call the Operation Navigator, and this keeps critical information accessible and facilitates reuse. We can use standard Windows commands of cut, copy, paste from right within inside of NXCAM, whether it be from one session of NXCAM to a whole different version of NXCAM. We're programming a different part in a different launched version of NXCAM. We can actually cut, copy, and paste commands, tools, operations from one session to another. Provides a rich information environment, displays the operation sequences, dependencies, while tracking tool usage and facilitating associated part data. Across the entire user interface, we use the latest methods of making the user interaction fast and easy. Simple example is the use of diagrams in the menu dialogues to show the user what data is needed. The top image that we show there, basically with inside of any dialog box that you would select, the image in that dialog box on the right-hand side will change dynamically. So whether or not I'm selecting wind gouging and retract, and I hit this drop down, it'll show me the different options within inside of it and automatically change the dialog box associatively. Also, anytime that I maybe or try to put in some clearances for my tool holder or shank or tool neck, it'll automatically change the dialog here, again, showing what information that I'm filling in at that given spot. Also, with tools like Command Finder, I can easily find commands that you maybe forgot where they were located, or maybe you know the equivalent of the command inside of a different command CAM tool. You can actually type that command within inside of our Command Finder, and it'll automatically go out and try to find the most common one and show you exactly where it's at within inside of NXCAM. Siemens provides a complete CAD-CAM system all within inside of NX. You have the full range of CAD functions, can be extremely useful for the CNC programmer. With NX, it does not mean jumping from one CAD program into another CAM program. The CAM environment's all within inside of one system, one software. Basically, all you're doing is turning on or off different toolbars. You can also expand out into other areas such as tool design and molds, dies, or build out a complete part manufacturing solution. With the integrated solution that Siemens provides with the CAD-CAM with inside of NX, we also have what is called Synchronous Technology. This is core within inside of any NX-CAM module. It provides a wide range of additional manufacturing applications, such as being able to manipulate, modify part data, whether it be imported or whether it be the actual NX CAD data itself. Show a quick prime example of this.
NX provides powerful model editing functionality, and we call this synchronous modeling. It's available in the standard CAM packages, and it allows the NC programmer to make quite complex adjustments to a model prior to doing the NC programming. In this case, the user is going to select these whole features here and ask the system to cover them with a surface that matches the surrounding surface, making it easier to put a toolpath over those areas. In these second and third examples here, the user is selecting quite complex geometry and asking it for it to move to a new position or editing like in a critical dimension. The system takes care of the edit, even though the geometry surrounding it is quite complex. So this provides a very powerful solution for the NC programmer that needs to be
So again, with Siemens and NX, it provides a complete solution set to define a part manufacturing plan and take it to the shop floor for execution. This diagram represents our view of a complete part manufacturing solution. This solution combines the Siemens PLM software manufacturing engineering application and connects all the way down to the Siemens motion control with the Synchronous. It also includes in the signature Team Center managing the entire process all the way from concept through design all the way down to the production environment. Again, I want to thank everybody for their time this afternoon. Hopefully it was time well spent. Some upcoming webinars that we have that we're hosting this coming Thursday at 2 o'clock. The automated mold design with Mold Wizard. Again, that's July 19th at 2 o'clock. You can register by visiting our website, www.camlogic.com. Again, there's our contact information. Feel free to check us out on YouTube. This video will be up there a couple days. Follow us on Twitter and blog and LinkedIn. I'm going to open it up real quick for questions. Again, on our if you look where you logged in, you can actually type a question there, and we'll do our best to answer it. I'll leave it open here for a little bit. Feel free to fire away. All right, well, again, I appreciate everybody's time. I'm not seeing anything come in so far with any questions. If you do have any questions that come up later, feel free to give me a call here at CAMLogic. Do our best to answer it. And if you'd like to schedule a one-on-one demonstration of NX in your environment, again, feel free to give us a call, shoot me an email, and we'll get something on the calendar. Thanks again for your time, and